Okay, dear students, we're going to go ahead and get started by going over some review problems on complex numbers. So let's take a look at question number 1. If I equals the square root of -1, then what is the value of 7i times -8i times 9i? So what you want to remember is that I cannot have a power that's bigger than 1. If it has a power that's bigger than 1, it must be reduced, okay? So remember, I is the same thing as I. If you have I squared, it must be reduced to -1. If you have I to the third, it's simply a product of these two, which is -I. And if you have I to the fourth, it's simply I squared, which is +1. Okay, so let's keep that in mind. To simplify this product of pure complex numbers, we're going to do two at a time. So 7 times 8 is 56. So 56, -56i squared. All right, -56i squared times 9i. -56i squared can be reduced into +56 because I squared is -1, and then -1 times this negative right here makes that a positive. So we have 56 times 9i, and then when we multiply 56 by 9, we get 504. Okay, so this becomes 504i. So we can clearly see that our answer here is option letter A. Okay, now let's move on to problem number 2. So in number 2, we are asked to find the absolute value of a complex number. So let's say Z is our representation of a complex number, and it's given by 7 minus 4i. So remember that to find the absolute value of a complex number, magnitude of Z is equal to the square root of a squared plus b squared. Okay, it's just like the Pythagorean theorem here. So that's exactly what we're doing. Okay, you can view this as a, b, and then this right here is c. All right, so if I wanted to find the absolute value, I'll have z squared is equal to, like c squared is equal to 7 squared plus -4 squared. How did this happen? We remember that from the Pythagorean theorem, c squared is equal to a squared plus b squared. And if you have this complex number, a is the coefficient, is the real part, and b is the coefficient of the imaginary part. So a is 7 and b is -4. So that's how I came up with this expression right here. Okay, this equation, sorry. All right, I'm going to simplify. We have z squared equals 49. My -4 squared is 16. So z squared is equal to 65. And then to finish this off, you take the square root of both sides to get the norm of z, and that's going to yield the absolute value of z, which is the norm of the complex number, equals the square root of 65, and we can clearly see that our answer is option letter A. All right, let's take a look at problem number 3. We have a complex number, and we asked that what is the equivalent form of this number right here. So we have 2 divided by 7 plus 3i. We need to express it in this form. So in order to do that, we need to get rid of the I in the denominator. All right, so in order to accomplish that, we'll simply modify this expression by multiplying by the complex conjugate. All right, so 7 minus 3i at the bottom and 7 minus 3i at the top. Now, how did I come up with this? To get a complex conjugate, all you do is just invert the sign of the imaginary part. Okay, so this was plus 3i. You do the opposite, -3i, that's how you come up with the complex conjugate, all right? So on the top, we have 2 times 7 minus 3i, and then in the denominator, if you follow that out, you're going to end up with 7 squared minus 3i squared, okay? So if you look at the denominator, if you follow this out, the two middle terms cancel out, so you always end up with something like this. Or if you think about the difference of squares, if you have a plus b times a minus b, the expanded form is always going to be a squared minus b squared. Okay, the reverse of the difference of squares factorization formula. That's what I'm applying here. Okay, so let's go ahead and simplify this a little bit more. Let's leave the 2 outside. We might be able to divide the resulting number in the denominator by 2, so let's leave 2 undistributed, and then leave the numerator expression like this. And in the denominator, 7 squared is 49. Now what is 3i squared? 3i squared is 9i squared. Do not forget to distribute this 2 to the 3 and the I. The product of powers property, the power of a product property of exponents require you to distribute the power to the factors that are being multiplied in the parentheses, okay? So 3 squared is 9, I squared is I squared. Now remember I stated earlier that if you have a power of I that's greater than 1, it must be reduced, okay? So what's the reduction formula that we're going to use here? I squared is equal to negative 1, so let's apply that. So we're going to have 2 times 7 minus 3i divided by 49. Since I becomes negative 1, it inverts this sign to a plus 9. Okay? So that now becomes 2 times 7 minus 3i over 58. Alright, so to reduce this, we just divide the numerator and the denominator by 2. So 2 goes here 1, 2 goes here 29 times. So our final answer for number 3 is going to be 7 minus 3i over 29. And the final answer is option letter B. Alright, let's take a look at the next one, number 4. So number 4, we are asked to evaluate I to the 41st power. Now, and keep in mind the fact that I is equal to negative 1. So how are we going to do this? To do this, we're just simply going to divide the power by 4, and all we care about is the remainder. So if you divide 41 by 4, the remainder is 1, so it's basically I to the first power, which is I. So we can clearly see that the answer is A. Okay? So how I normally showed you guys how to do it before is if you do I to the 41, it's the same thing as I to the 41 mod 4. Okay? What is 41 mod 4? 41 mod 4 is what is the remainder after 41 is divided by 4. So 41 mod 4 is equal to 1. Because when you divide 41 by 4, you get 10, remainder 1. And this is the modular value that we're looking for this expression. All right? So this expression simplifies to just I to the first power. Remember, if I has a power that's 1, it cannot be reduced, so you just left with 1. Okay, only if the power is bigger than 1 that you can reduce it using the reduction formula that we talked about earlier. So we can clearly see that our answer for number 4 is option A. All right, let's take a look at problem 5. So we're asked to graph this complex number 2 plus 4i. So how do we graph something of this nature? Well, we want to convert it into a coordinate form. So the coordinate form of a complex number a plus bi is simply the coordinates a comma b. The real part corresponds to the x-axis numerical value, and then the b, or the coefficient of imaginary part, is the y-axis. Okay, so if you notice how it's done here, this is the real, just like the x-axis, and then this is the imaginary part. Okay, so to graph this complex number on a complex plane, you're just simply going to be graphing the points 2 for the x coordinate and 4 for the y coordinate, 2, 4. So you go to the right 2 and up 4. Which point here corresponds to this plot? Let's figure it out. 2 units to the right, 1, 2, up 1, 2, 3, 4. That's our answer. We can clearly see that option C is our correct result. All right, let's take a look at problem number 6. It says, what is the difference between, when 9 minus 2i is subtracted from 4 plus 8i? All right, so you have to be really careful the way you order this. If this is subtracted from that, it's written as 4 plus 8i. You're subtracting this from that, so it's 4 plus 8i minus 9 minus 2i. All right, so the way it's written and the way it's written numerically and the way it's written verbally are like opposites. Okay, so if you're subtracting this from that, you have to say this subtracted from that. But if you're writing it in numerical form, you have to write the 4 plus 8i minus what's being subtracted from it, which is 9 minus 2i. Okay? So having it set up like that, to simplify it further, we have 4 plus 8i. And then you distribute the negative to this number, you have negative 9 plus 2i. And then you can add downwards, because adding is the same, subtracting is the same thing as adding the opposite. So add downwards, you have negative 5 plus 10i. And we can clearly see that our answer is option letter A. All right, let's take a look at problem number 7. It says determine the 3 equivalent expressions. So we have 6 expressions here, and 3 of them are equivalent. So all we just have to do is express every single number in a plus bi form. And if the a's and the i's and the b's match, then they are equivalent expressions. Okay? So let's take a look at option letter B. All right, so A is already in this form, so let's leave A alone. If you look at B, we're multiplying here, so we have negative 14 plus 2i multiplied by 1 plus I. So we're going to do first outer, inner, last. First outer, inner, and then last is plus 2i squared. Okay, this becomes negative 14. Combine the middle terms, you have minus 12i. And then the last one will be minus 2, which reduces into negative 14 minus 2 is negative 16 minus 12i. Okay? All right. Now let's all right, so let's put it in. B is negative 16 minus 12i. All right, option C is already in a plus bi form, so let's leave that alone. Let's take a look at option letter D. Put that in a plus bi form, so we're going to multiply negative 6 plus 8i by 1 plus I. So we'll distribute first outer, inner, and then last is going to be plus 8i squared. Okay, so this becomes negative 16 if you add the middle terms. If you combine the middle terms, you get positive 2i plus 2i, and then this last term here becomes minus. Okay, let's do this one again. So we have negative 6. All right, and then we combine these two middle terms, you have plus 2i. And then the last one is negative 8, because the I squared changes this to minus. And then when you combine the real part, you get negative 14 plus 2i. Okay, so this one is negative 14 plus 2i. All right, so we can see that A and D are equivalent expressions. So let's see which of these two, if one or both of them match these two expressions. All right, so let's shift our attention to option E. This one involves subtraction, so I would like to do it vertically. Negative 9 plus 20i minus 4 times negative 1 plus 4i. So we're going to have to distribute this term. Distribute negative 4 to this term, so we have negative 9 plus 20i equals 4 minus 16i. All right, and then we add it downwards. This yields negative 5 plus 4i. Okay, so that doesn't match A and D, so that's not an equivalent expression. So last but not the least, we have option F. So that is also a difference problem, so I'm going to do it vertically. Negative 32 plus 29i minus 3 times negative 6 plus 9i. All right, we have to do the distribution here again. So we have negative 32 plus 29i. Distribute negative 3 here, we're going to have positive 18 And then if you distribute negative 3 here, we're going to have minus 27 I. All right? And then we'll just combine downwards. So we're going to, let's draw the line here. So this was for E, this was the sum, or the difference. And then for this one, let's find what the difference is going to be. All right, so if we combine the real part, negative 32 plus 18, you're going to get positive negative 14. And then if you combine these two, you get positive 2i. All right, so this one is equal to negative 14 plus 2i. And we can clearly see that it matches A and D. So the conclusion here is that three equivalent expressions are A, D, and F. Okay, are equivalent. So there you have it. So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel, post a comment to let me know what you think or if you have any questions. And also you can share and like via your respective social networking program. Thanks again for watching. More clips can be found on math.chef.com. Have a wonderful day.